Continuing with the derivatives of functions that are not polynomials, we're going to look at the derivative of the exponential function. So when f of x is equals to a to the exponent x. And the question is, what is the derivative when f of x is equals to a to the exponent x? So in other words, we are looking for d dx of a to the power x from first principles. And to do that, we are going to do the limit of the difference quotient, which is what? A to the power x plus h minus a to the power x. Remember that you replace, to get f of x plus h, you replace the x by x plus h. So that's what you have. Now, we have this equal to, as it approaches 0, we have what? X into a to the power h minus 1 over h. Okay. Now, from there we have what? Limit of h, limit of this expression as h approaches 0, but we see the x there. A to the power x doesn't have h, so it's not affected by the limit. So we assume you can take it behind the limit if it's a constant with regard to the limit. So we take it behind the limit. Then we are left with a to the power h minus 1 over a to the power h. And this limit here, very interesting. Actually, is the same as the natural log of a. But we won't discuss as part of this lesson why this is the case. But we can basically explain it. But we just don't want to explain it in here. That's it. It approaches, or rather its limit is the logarithm, natural logarithm of a. And that is the derivative of a to the power x. It's a proportion, or rather it's a multiple of the same function. Okay. Now, let's go to another function. Let's go to the derivative of ln of x. Another interesting one. We're going to have what? From first principles again, we're going to have the limit of the difference quotient, ln of x plus h, all over, minus ln of x all over h. Right. Now, with this, we are going to have the limit of now remember the laws of logarithms allow us to write this as what? X plus h all over x. Right. All over h over 1. Remember that the log of BC is equals to the log of A, B plus the log of A, C. Or another way, if we have log of B over C, then when you change it, it becomes log of B to the base A minus log of C to the base A. So that's what we did here. It was ln of x plus h minus ln of x. That means it must have been ln of x plus h over x. But if you don't know the laws of logarithms, then you cannot proceed here. So now let's go on. This becomes what? The limit of ln of, we simplify, this is going to be 1 plus h over x, right, multiplied by 1 over h. Or we can just leave it like this. Let's leave it like this. Let's just leave it like this, over h. Right. Now, or rather, it's fine. Let's say it's h over 1, and then let's multiply here. 1 over h. Yeah, if we do that, that's fine. It's a bit of a trick, rather. Now, when we do this, we say, when you proceed, this is a logarithm. So, this multiplying the logarithm is the same as saying what? 1 h over x to the exponent 1 over h. And the reason here is that log of a to the exponent x really is the same as log of x log of a. If you remember the log laws, log of a to the exponent x is the same as x log of a. In this case, we had 1 over h ln of 1 plus h over x. So that means we can take the 1 over h and raise it back to the exponent. So the h is here, 1 over h is here. Even though you can write it here, I mean, it's in the front, it's the same as it being in the back, because at the end of the day, it's the log times the x. You can take the x to the exponent, and that's what we did here. The 1 over h is multiplying the log, so we can make the log the exponent. Now, by doing that, now we have an interesting limit. Now, this limit, we must remember, or rather, we must know there's a limit that says, let's say Sn approaches 0 of 1 plus x over n to the exponent n is actually equal to e. There's a limit, Sn approaches infinity, sorry. There is a limit that says this. And there's a whole discussion on how we can get this, and we can go into that argument in other videos. But here, we just take it as it is. And if you look at what we have here, this is almost like this one. If you check what we have here, it's almost like the same structure as that. The only difference is that the x is at the bottom, and also this is not approaching infinity. So what do we do? So we transform this. Here's how we do it. We write limit. If you make this 1 over h, then this goes towards infinity as h approaches 0. So we start by doing what? We change to 1 over h. So we say if h approaches 0, then 1 over h approaches infinity. I mean, if h becomes smaller and smaller, then the 1 over h becomes bigger and bigger. I mean, take for example, 1 over 0.1 is 10. 1 over 0.01 is 100. 1 over 0.001 is 1000. 1 over 0.00001 is 10 million, and so on. So as n becomes closer and closer to 0, or as it gets closer and closer to 0, 1 over h gets closer and closer to it, rather it becomes bigger and bigger infinitely. Okay, to say it gets closer and closer to infinity suggests that infinity is a certain point that you can reach. Well, it's better to say it becomes more and more bigger, right? So let's see. After changing this to 1 over h, what we can have here is ln. Then also here we want what? 1. We change to 1 over h so that we have 2 infinity, so that it looks like this one. This one here, in order for us to use this result, we need to have the n, here, which is at the bottom, becoming infinity. Now, as h approaches 0 here, we know that 1 over h approaches infinity. So that means even in our expression here, we must have 1 over h at the bottom. Right. So that means in the bracket, and then we must have 1 over h also in the exponent. We already have 1 over h there. We've changed this to 1 over h, and then it goes to infinity. Now we must make sure there's 1 over h in the bottom. And this is exactly how we do it. We're going to say we have 1 over x over 1 over h. If you don't believe that h over x is equals to this, we can work it out here. We can say 1 over this divided by 1 over h is the same as h over 1. Remember, when you're dividing two fractions, you change to multiplication and invert the other fraction. So I changed to multiplication and inverted 1 over h to h over 1. 1 times h is equals to h, x times 1 is equals to x. So that means this is the same as the h over x. But by so doing, now we have this 1 over h, 1 over h, and 1 over h, which is the same as having limit as n approaches infinity of ln of x the result doesn't say, it says e to the exponent x. Sorry, I forgot the x there. Okay, so if it is e, just e, is because the x is equals to 1. My bad, sorry. Okay, so here we're going to have what? Just going back to the problem, we're going to then have 1 plus 1 over x over n to the exponent n, which is exactly the same as this result here. Look at them together. These two things here are exactly the same. N is in the same place. N at the top, n at the bottom, n to infinity. N at the top, n at the bottom, n to infinity. Except here we have 1 over x, here we have x. That means that we can replace this with what? With e. But our e cannot be to the exponent x. It will be to the exponent. Before we do that, this is I missed one step. Sorry, let me just go back. Before we can use this result here, it doesn't have the logarithm or the ln, which is here. So we are going to do this, and here we assume you can take the limit inside or in front of the log. So we'd have the limit inside of n approaches infinity. So we'll use brackets here. And then of what? 1 plus 1 over x over n, all to the exponent n. And so this gives us exactly that result that is there. This gives exactly the result that is there, except it's not x is 1 over x at the top, but n is the same way everywhere. Bottom, top, here on the limit. Top, bottom, here at the limit. Okay, so that means we have ln, in other words now, ln of e to the exponent 1 over x, because ours here is not x but 1 over x. But this by definition then means that we have 1 over x and ln e. Ln e, if we remember, ln e is the same as log of e to the base e. And this by default, by definition of logarithms is 1. Okay, the log of e to the base e. So that means that what we have then here is actually 1 over x times 1, which is 1 over x. And that is how we get the logarithm of the ln of x. Okay, a very important result here. You can note it down And there are so many books you can check this in, or check our videos. At some point we'll record a video explaining this. Okay.